Hi, I'm Chuck St. Louis, and I'm an author for the Home Shop Machinist Workshop. And I have an engine that hopefully will be published in a future publication for Village Press. Down below here is a Hotair engine. It's a coaxial engine. It has the displacer rod for the displacer going right through the piston, so it makes it coaxial because both the displacer piston and the power piston share the same axis. The cylinder is made of steel. Likewise, the power piston. They're hardened steel and lapped to a very close fit. And it has a link here. The link is what sets the timing off by 90 degrees to put them out of phase, so it works as a Hotair engine. So I'll put it together here. We have a flame here, alcohol flame, and I don't use a clamp. I prefer to use tape. I find it easier on the test tube and less chance of cracking the test tubes. And it's easy to change, and you can use the tape over and over again. Get it to heat up a little bit here. It's better that the displacer is towards the power piston, away from the flame, while the test tube's heating up. Just about there now. It's starting to run. I've never checked the RPM on it, but it can run quite quickly depending on the adjustment. A little bit of a squeak there because it's just touching the glass tubes are touching each other. But actually, it's quite nice to hear it run. To see it run slowly, you can appreciate more the mechanism. It runs quite quickly. The timing on this here is set here through this link. You can see here, I can slip this screwdriver through this space here. If I adjust that distance, it's not all that critical. It will continue. It'll run quite well even if it's changed. I'll set it so it's a little bit closer in, about 1/8 of an inch. So that changes the length of the stroke, but at the same time changes the timing a little bit. So it's not that critical. It'll run even if the timing's not perfect, or the stroke is at a different length. It'll continue. It'll run well. So that's not very critical. What is critical with these engines is that the fits and the tolerances are good and everything lines up and it's free and there's no friction. That has to be taken care of, and if those things are obeyed, it will run quite well. Both connecting rods are made of aluminum. As you can see, I've got quite a large mass here on the flywheel to balance the system, and for that reason I used aluminum here, but the rest of it's steel, so I don't have to use lubrication, and it runs well. It's not fragile like a graphite piston and glass tube because it's steel, and it's quite durable, and because it's hard, I hadn't tempered it at all. The coefficient of friction is very low. So it's a pretty good runner. I hope you enjoy, and I'll take the heat away, and as with all Hotair engines, when you take the heat away, it will continue to run as long as there's enough temperature difference. Let's turn it around here so you can see the mechanism a little bit. As you can see here, the rod's sliding back and forth in the piston. And you get a little bit of squeak here. It's a little bit out of adjustment. The tube here, the tubes aren't really straight, the ones that I purchased, but they work. They scrape a little bit, slows the engine down. So that's it. Thank you, and bye for now.